Hey everyone, I'm obviously not in today, so instead you are watching this video of me demonstrating the lesson. It's kind of going to go the same way that we would in class, where you would follow along. You're going to take notes in some parts and follow along with examples as well. Once you're finished watching this video, you're going to work on the classwork that I assigned to you on Edulastic. I did post the link on Google Classroom, so you can click on that and it'll take you directly to it. Otherwise, you can just log into Edulastic and work on that as well. So it's just going to be practice on what I'm demonstrating today. Your classwork is worth 15 points, so just be sure to get it done on time. You have no warm-up today. All right, so for today, we're going to be working on solving systems of equations by graphing. So last time we met, we talked about solving systems using elimination and using that elimination method. Today we're doing the same thing, but instead of elimination, we're not doing it algebraically. Instead, we're doing by solving. There is no warm-up. Again, like I said, you are watching this video, so you're completing the first step. And then again, once you're done, you're going to complete the classwork on Edulastic. And this is important in order to solve systems of linear equations approximately. Sometimes it's not going to be exact, and we'll talk about that a little bit later. Okay, so go ahead and pause right here. So pause the video and then copy this page into your notes. You're going to copy every single thing down, including the chart. That's the most important part. All right, so you should have paused this video. So let's talk about a system of linear equations. So a system of linear equations is two or more linear equations that define a relationship between quantities. Okay, so once you solve a system, you can have different types of solutions. We've talked about the different types of solutions, but this is what it looks like with a system, because with a system, you have more than one equation. So the first one is for you to have one solution. So one solution would technically be a consistent system. A consistent system just means that your two lines, once you graph them, they meet at some point, at least at one point. So if you have one solution, it's a consistent system. So here's one solution that makes both equations true. And this is found at the intersection of both lines. So technically, if I graph my two equations and they meet at an intersection point, that is the solution. So this would be the solution. And again, this is a consistent system. The next one is a consistent system as well, and this is when you have infinite solutions. So infinite solutions is when two equations of the same line, one on top of the other. So these are essentially the same equation. So if you graph the same equation, it's going to be two lines on top of each other. So any point on that line is technically a solution. So it's kind of hard to draw a straight edge on here, but all of those are solutions. So because of that, because lines continue on forever, there's an infinite number of solutions. So both of these are technically considered consistent systems. And again, they're consistent because they have a solution. The last option is no solution. This happens when you have a system with no solution. So parallel lines have no solution because they have the same slope, different y-intercept. It means that they'll never meet. Again, that's an inconsistent system. So let's go ahead and look at some, practice problems. So follow along with me in your math notebook. The nice thing about this is you can pause the video at any time if you need to finish copying. So we are to solve each system by graphing. Okay, so let's go ahead and start off with number one. So for number one, you have two equations. The first one is y equals -5 over 3x plus 3. Second one is y equals 1/3 x minus 3. So what I'm going to do is go ahead and graph my equations. So I'm just going to go ahead and number them. Here's equation 1. Here is equation 2. Okay. Actually, I'm going to even use different colors. Here's equation 2. So for equation 1, again, we're just going to graph this the same way we were graphing back in the days when we were practicing these. To start off, I'm going to write down the two things that I need to graph. So that's my slope and my y-intercept. So my slope is m equals -5 over 3. My y-intercept is b equals 3. Again, just to review a little bit, remember your slope is always found in front of x. Your y-intercept is always found after x. Okay, so there's my slope and my y-intercept. I'm starting off with my y-intercept. My y-intercept is found at 3. So I'm going to go up to 3. plot my point, and then I'm going to move with my slope. My slope is always a rise over run. So let me write that down. It's a rise over run. So that means I'm going to move down 5 units and to the right 3. So I'm going to go 1, 2, 3, 4, 5, and then to the right 3. 1, 2, 3. So my second point is right here. Last thing to do is to connect them with a straight edge. Make sure you are using a straight edge as you're doing this activity. That's super, super, super important. And then make sure that both of your lines have arrows at the end to show that they continue on forever. I'm going to do the same thing with my second equation. So I'm going to write down my slope, write down my y-intercept. So my slope is 1/3. My y-intercept is -3. I'm going to highlight both of those, show you where I'm grabbing that information from. Okay, and the same thing, my slope is my rise over run. I'm going to start off with my y-intercept. So I'm down at -3, and my slope tells me to move up 1 and over 3. 1, 2, 3. And look at that, they actually are going to cross there. So let me go ahead and connect this using my straight edge. All right, so that's my second line. And you could see that my lines do intersect. And because they intersect, this is a consistent system. They intersect, so it's consistent. And I have one solution because they intersect once. This point right here is my solution, so I'm just going to write the coordinates for it. The coordinates for it are 3, -2. Okay, so just see where those meet. 3 and then -2. It's always your x and then your y. So I'm just going to write that down, and this is my answer. All right, let's go ahead and practice another one. Again, if you need more time to copy this down, you can pause this video now. Let's go ahead and try number 2. So for number 2, we have, again, 2 equations. So I'm just going to go ahead and number them. Here's equation 1. Here is equation 2. So again, this is essentially the same thing. The only thing that's different is that we're graphing 2 equations on the same coordinate plane. So for my first equation, I'm going to write down my slope, write down my y-intercept. So my slope is 4, but since I'm graphing, I'm going to put it over 1 because I want to look at this as my rise over my run. My b is 3. All right, so again, here's my slope, and then here is my b value. All right, let's move on to our second equation. My second equation, my slope is m equals -1. There isn't a number there, so remember you can always throw a 1 in there. Put it over 1, turn it into a fraction. My b is -2. Take the sign in front of it with you. So again, I'm going to highlight, show you where I'm getting this from. Here's my -1 over 1. And again, that's my rise over run. So I'm going to start off with my equation in red. So my equation in red has a y-intercept of 3. So I'm going to go up to 3, put my point there. Then I'm going to move with my slope. So for my first equation, my red equation, I have a rise of 4 and a run of 1. So I'm going to go up 4, 1, 2, and then I ran out of space. Okay. Now I don't want you to guess, because if you guess, it's going to be all wrong. Okay. You're going to end up approximating and it's not going to look good. So instead of going up 4 and then to the right 1, here's a nice trick that you can use. Okay. I'm going to do the opposite. So instead of going up 4 and up 1, up 4 and then to the right 1, I'm going to do the opposite. I'm going to go down 4 and then to the left 1. And if you do that, that'll be fine. Okay, it'll just give you another trail of points that are on the line that will fit into my graph. So I'm going to go down 4, 1, 2, 3, 4, and to the left 1. You do the exact opposite of what we would have done. So there's my new point, and then I'm going to connect my straight edge. You can always double check that you did it correctly. Oops. You can always double check that you did it correctly. I think, where did my straight edge go? Can't find it. Oh, it's up here. Ah, it disappeared. I don't know where it is. This is funny. Oh, it's up here. I see it. It's like on the corner of my screen. There we go. Okay, so let me go ahead and connect this, and then I'll tell you how you can double check your work. So, oops, moved it. There we go. All right, so there's my first equation. Now, I could double check that this is correct by looking at my line. My line is increasing and my slope is positive. So that tells me my line should be increasing. Oops, I'm highlighting stuff, and it is. So let me do the same thing for my second equation. Okay, hopefully it all fits on the graph. If not, we know how to fix it. So for my second equation, I'm going to start at my y-intercept. My y-intercept is at, I erased it. It's at -2. So here is -2. My slope tells me go down one, go to the right one. So I'm going to go down one to the right one. Take my straight edge that I haven't lost. Connect those. Okay. And I can see that this is also going to be a consistent system because they intersect. They intersect here. Okay. So I'm going to start off by saying this is a consistent system. We have one solution because they only intersect once, and I'm going to write the coordinates for it down. Okay, so the coordinates for that point are -1, -1, because I had to go to the left one and then down one from the origin. And that's my solution for number 2. All right, I have a few more examples to do. So if you need more time, go ahead and pause it, copy this down. Otherwise, I'm going to go ahead and move on to number 3 and number 4. Okay, so number 3, we're doing the same thing. We're graphing these two equations. For the first one, we have y equals -1/2 x minus 1. Again, I'm going to label. So my first one, I'm going to find my slope, find my y-intercept. I'm changing my colors. I'm going to stay the same, use the same red color for my first equation. All right, so my first slope is -1/2. My y-intercept is -1. You do the same thing for my second equation. My slope is 1/4. My y-intercept is -4. So I'm going to go ahead and graph these. For my first one, I'm starting off at my y-intercept, -1. Put a point there. Then I'm going to go down 1 and to the right 2. Since my slope is -1/2, I have a new coordinate and then connect it. Make sure you're using a straight edge every single time. All right, do the same thing for your second one. So start off at your y-intercept. Mine is -4. Then I'm going to go up 1 and over 4. So 1, 2, 3, 4. Okay, I'm going to connect the coordinates. Connect my 2 points together. Okay, and I can see that they intersect. So this is also going to be a consistent system. I have one solution, and my solution, I'm going to write it as a coordinate. So again, my solution is I went to the right 4 and down 3 from the origin. So 4, -3 is my answer. All right, we have one more practice problem to do. So number 4, I have, again, my 2 equations. So for the first one, do the same thing. So I have my slope, I have my y-intercept. So my slope is -2. I'm going to put it over 1 since I want it to be a fraction. And then my b is 2. For my second one, I have my slope is -2, put it over 1. I want it to be a fraction. My b is -2. All right, so let me go ahead and graph my first one. My first one is, sorry, I almost said it's -2 over 1, but I want to start at my y-intercept. So my y-intercept is at 2. So I'm going to start up here. My slope tells me to go down 2 to the right 1. So I'm going to go down 2 to the right 1, put my point there. I'm going to go ahead and connect those. So let me do that using a straight edge. Oops. Okay, let me do the same thing for the second one. So for my second one, I have a y-intercept at -2. And then my slope tells me to go down 2 to the right 1. So down 2 to the right 1. Again, we're going to use our straight edge to connect that. Okay. And as you can tell, these lines are parallel. Okay. These lines don't cross. You can also tell by looking at the slopes, your slopes are exactly the same, but you have different y-intercepts, which means these two lines are parallel. So because they're parallel, that means that they'll never cross. So I'm going to say this is an inconsistent system, and there's no solution. We can't put a coordinate because there is none. They don't intersect at all. Okay, so again, you could have a consistent system if they meet at least once. You can have an inconsistent system as well. So what you're going to do right now is you're going to work on the classwork that I assigned to you on Edulastic. There's a total of 9 questions on there, very similar to what we just worked on. Go ahead and work on that. Whatever you don't finish will be homework. It's all due by Sunday, Valentine's Day at 11:59 p.m. You don't want to spend your Valentine's Day solving equations, solving systems by graphing. I don't know, unless you want to, then that's cool. But otherwise, I hope you guys enjoy the rest of your day, and I'll see you next time. Bye.